So in this one, let's talk about the client server model. This is one of the most common ways through which two machines talk to each other. One acts as the client who demands something to be done from the server, and the server is the one who does the heavy lifting to get it done. For example, client says, "Hey server, give me the profile with this particular ID. Hey server, please delete the post with this particular ID. Hey server, spin up an EC2 instance for me. Hey server, send an email to this user. Hey server, do this. Hey server, do that." Now, the way your client tells the server what needs to be done is what this model describes. So whenever two machine needs to talk to each other, so here when I say machine, it could also be your end user's mobile device. It could be web browser. It could be literally anything. So the idea is the way the communication happens between the two is always over the network, because what's common between the two machines? The underlying network. So the communication happens over the network between the client and the server. And the two very famous protocols, out of which one is more famous than the other, that is used to exchange the data between the two is TCP and UDP. UDP, very few use cases use that, and it's not really like it's critical for very few set of applications, but most of the communications that you hear about, they're all TCP based communication, which is where we dive deeper into TCP and ignore UDP for now. So almost all applications that you see, almost all web applications, almost all backend APIs that you create, they all listen on web server. Web server understands TCP, over which the communication happens, because it is reliable. TCP inherently gives you those properties through which the communication layer between the two is reliable. TCP takes care of retransmission, TCP takes care of quality, TCP takes care of a lot of things, right? So here, some important properties that you definitely need to know about TCP. We will not go very deep into TCP, but something that you really need to know about TCP are: number one, the TCP connection requires three-way handshake for setup, which means that whenever your client needs to do some or needs to tell server to do something, and if there is no connection established between the two, this connection is established with a three-way handshake. When I say three-way handshake, it means your client sends something to the server acknowledges it, and then client sends a confirmation, right? This is a protocol specification. But if you understand this closely, you would realize that if two machines are very far from each other, client has to send that packet all over the network to the server has to then send an acknowledgement to the client that it is okay to establish the connection, then the client acknowledges it again. So this three-way handshake requires you to do packet movement thrice over the network. So it is expensive. But if you want to use TCP, this needs to be done. So every time a TCP connection is established, this is what is happening behind the scenes, a three-way handshake, right? Apart from that, when the job is done between the between the client and the server, and now either one of them wants to terminate a connection, what happens? There happens a two-way tear down, which means your client sends something, "Hey, please terminate a connection." Server says okay, and connection terminated. So two-way handshake for the tear down. So three-way for setup, two-way for tear down, which means that if you're establishing TCP connection every time between your client and the server, three-way handshake will always happen, two-way tear down will always happen upon termination. Okay, so here, one key thing to remember. A lot of people think that, hey, once my request is sent and I get the response, my connection is broke. Not really, not necessarily. The TCP protocol does not enforce anything like this. TCP protocol does not say that, hey, once your job, like once you send the data, I send the response and it's done. No, the TCP connection does not break immediately after the data is exchanged. It remains as is. It breaks only when there is a network interruption. Due to any reason, if any switch in the network, the actual physical hardware switch I'm talking about, if that flips, that breaks a connection, that reboots, something like that. If there is a network interruption between your client and the server, that is where the connection is terminated. Number one. Number two, when either party, client or server, wants to terminate a connection. Until then, the connection remains open forever. Always remember this. Your TCP does not enforce a termination. It's up to the involved parties, the client and the server, to decide when to terminate, or either due to some unforeseen circumstances, the network itself terminates, or rather network itself interrupts the connection, right? Okay. So TCP is just about establishing the connection, and it's about whatever data I can send. I can define any way through which I would want to send the data. TCP creates those packets and sends the data over the network. So TCP takes care of that. Now, the way your client can tell server, hey, invoke this API, hey, do this, hey, do that, that protocol is totally up to us. So TCP does not dictate what data can be sent over it. It's up to us on how we want to do it. TCP just takes care of taking the data from one place, putting it into another, or rather chopping it into bytes and sending it and sequencing those bytes and whatnot. These are internals of TCP. You can explore it on your own. But the idea is your TCP does not restrict on what can be sent in it. It's up to you on what we want to do with it. Now, a common format, which means that in whichever format your client sends the data, your server needs to understand it. And or rather vice versa. So for anyone to talk to the server, they need to send data in a particular format, right? So this is exactly how humans communicate. If I communicate in a particular language and you do not understand that, then you don't know what to do with it. That exact same thing is what message I'm trying to communicate needs to be sent in a particular format to you so that you understand it. This is what a common protocol between us is, the common language, in this case English. Right? So similarly, a client and a server agrees upon a common language that tells the server, hey, what I need to do with that, which is in most common cases HTTP. Your client sends an HTTP request. Your server understands that, hey, if I get this bytes, if it has this kind of format, it is an HTTP request. So it knows what to do with it. And then it does that appropriate things and sends back the response in the HTTP response format, which client understands. So HTTP is the common language of communication between your client and the server. And it is by far the most common one out there. So HTTP, if we go it, because HTTP is the most common way, so we need to know it in depth. So HTTP is just a format in which a data is sent from the client to the server. When I say data, it means a request, which means you are telling the server what needs to be done and your server needs to understand. So HTTP is just a format through which you are able to send the data. So HTTP request headers, response headers and whatnot, the body, there is a protocol specification of HTTP that both the parties, like the client needs to encode it, send it, server needs to decode it, understand it, do the action, generate the response, send the response to the client, client understands the response and does whatever it needs to do with that, right? So this is a format. Now this means because TCP does not dictate that it only has to be HTTP, which means that you can define your own custom format so long as your server understands it. As simple as that. For example, if I'm writing a simple key value store, I can define my own format that, hey, once the TCP connection is established, I would send GET space K and a /n. As soon as you get /n, understand that that is a command. And the first word, you split it by space. The first thing that you do, the first thing that you get is the command that you would want to run. Second thing is the key that I want you to do with it, like whatever arguments that command is. Now this is a format that you defined. So long as a server understands it good enough. HTTP is a common format that most web servers understand, which is why the world is working with HTTP, but it does not mean that you cannot define your own format. So long as your server supports it, your server understands it, your server knows what to do when it receives a command or a set of input over the TCP connection, you're good, right? So always remember, almost everything in computer science is all about abstractions. This has been abstracted. TCP just takes care of sending the data from one place in a reliable way to other. Now, what data you send, how that other machine interprets it, it's our headache. It's our TCP's headache. So you can define your own custom format also. You can use HTTP, you can use WebSockets, you can use HTTP2, anything. No one cares about it. The idea is so long as your client knows how to send, your server knows how to interpret and get it done, good enough. This is something that you should always remember, that HTTP is not an enforcement. You can define your own format as well. For example, let me give you a practical example. Redis does not use HTTP to get the key, put the key, delete the key. It has defined its own custom format, which is optimized for its own use case, right? So a lot of tools, a lot of databases, a lot of technologies, they write their own custom formats, but then which means that you need to have your own clients to do that. But the idea is you keep it agnostic. It's up to you. HTTP is a common way to do it. It's a common way to do it, right? Okay, so in most cases, the HTTP, the API servers that you write will mostly be in HTTP, but it need not be that it can only be in HTTP. Be open to other possibilities, right? Okay, now HTTP as a protocol have multiple specifications. HTTP 1.1 is by far the most adopted. The world is now, a part of the world has moved to HTTP 2 and a very small fragment to HTTP 3. But in most cases, you would always see HTTP 1.1 still used very heavily in production, which is what we'll go through the key things that you need to know about HTTP 1.1. HTTP to HTTP 3 are just enhancement on top of it, but this is bare minimum that you should definitely know. So HTTP 1.1 is the most commonly used one out there to date. So for a client and server to talk over HTTP, they need to first establish the TCP connection. It can also happen over UDP, but in most cases it is TCP because it is reliable. So now what happens is, in HTTP 1.1, your connection is terminated by the web server as part of specification when it sends the response back to the client. So your client wanted to get something done from the server. Client created a request, made a request to the server. Server received the data. Server generated a response. Server sent the response to the client, and the connection is broken. This is a very common behavior that you see while you write HTTP based web servers. It is typically terminated. It is not an enforcement, which is where you see a header like keep it alive or keep alive header. Just Google about it. So if this header is passed, your server would not terminate the connection so long as the server supports that header, right? But the idea is that typically your connection is broken once you send the request, you get the response, your TCP connection is broken. So you almost tend to create a new connection for every request response, which is expensive because three-way handshake, two-way tear down, one request, one response. So for one request and one response, we are sending 3 handshake for creation and 2 handshake for termination. So it gets very expensive. But as I said, that it is not mandatory that, hey, I have to always terminate the connection. There are modern web servers that understands the header connection keep alive. So you pass the key as connection and value as keep alive in the HTTP header. Google about it in case you are unaware. Very simple thing, but Google about it to get a deeper understanding. Now here what happens is when you pass this header while making the request, it tells the web server to not terminate the connection unless explicitly asked. So this is how your server, so it's up to the server to decide if I want to terminate or not. When it gets keep alive, server does not terminate the connection. Which is what I was saying, that TCP does not enforce a termination of connection. TCP says, hey, my connection will open forever unless there is a network interruption or you folks chose to decide to terminate. So here, keep alive header is a way for your client to tell the server that, hey, please don't terminate the connection. I might reuse it again, right? So this is how it looks like. There is no hardbound rules to anything. Everything is flexible in the world of software engineering. Always remember this, right? Okay. Now the next one that I'd like to talk about is WebSocket. WebSocket is the heart and soul of any real-time application, right? So WebSocket WebSocket is meant to do bidirectional communication. Now what is bidirectional? So over here in HTTP 1.1, what we saw was client had to invoke an API to the server for which it needs to establish the TCP connection, fire the request, get the response and terminate the connection. Now that is expensive. And here your client had to make a request for a server to do something. Now what if your server wants to proactively send data to the client? That could never happen. This is a limitation of having unidirectional communication, which is what WebSocket solves us for. So what WebSocket solves us, it solves us for proactive communication from the server to the client without client asking for it. I'll give a practical example for that. Imagine you are building a messaging application, Instagram messaging, LinkedIn messaging, anything. Right? Now, one way for you to receive a new message is, hey, you have established the connection. Periodically, you make a call to the backend server to check, hey, do I have any new message? 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 You keep pinging the server, which is short polling. You're polling the server to see if there is something new for you. If you have something new for you, you immediately render it in the UI. The message you get in the response and you render it in the UI, right? That is one way to do it. But if you look carefully, making request every few seconds is very expensive. Now, to give a very rich user experience, it is always better that your server proactively pushes the incoming messages to the user. This happens, or this requires servers to proactively push the data to the client, which is what bidirectional communication is all about and is facilitated by WebSocket. So if this pictorial representation of it tells exactly what happens behind the scenes. So for WebSockets, your client has to initiate a connection to the server, because server don't know client's IP unless the connection is established. Your client establishes the connection with the server. Once the connection, so this is a normal TCP connection. Once the TCP connection is established by doing a three-way handshake, then the connection is not terminated unless there is a network interruption or both of them decides to terminate. So connection remains as is, and the actual data is sent one after another. Any real-time messages, stock market ticker, whatever, you can build a lot of real-time stuff for that. But if you look carefully, there is no termination in between unless all the data is sent, or until wherever the connection remains open. There is no termination at all, which means that once the connection is established, all of your latencies are literally transmitting the actual data and getting the actual data. No overhead of anything. So this is why it is used to build real-time applications. For example, messaging apps, chat applications, real-time experiences. We'll talk about those use cases in some time. But if I were to do this with HTTP 1.1, what would happen? You would have three-way handshake, one request, one response, two-way teardown. Then again three-way handshake, one request, one response, and then two-way teardown. You look closely that here we did so much of actual data transfer rather than worrying about just handshakes for creation and termination. Here every time after you send request and get response, you have to terminate it, and so on and so forth. So this is a very significant overhead when you use HTTP 1.1. When you say, Arey, but if there is a problem, then why are we even using HTTP 1.1? Why can't we just use WebSockets for all? Persistent connections are very costly. You should not have, because it puts a lot of load on your server. So unless there is a very specific need for you to have those connections open forever, having those persistent connections, it only makes sense when you need them. Otherwise, you don't need it. This overhead, a lot of companies, a lot of products just accept because it's fine. Right? Because managing WebSockets is a huge pain. So always remember when to use WebSockets. Whenever you need anything quote unquote real-time low latency, this is where WebSockets are your friend. Because this is where your connection is established, and then only latency that you incur is for actual data transfer and nothing else. So practical use cases of this is chat, real-time likes on live stream. So let's say some of your favorite celebrity went live on Instagram. There is a small heart button that you press, you tap on it. On celebrity's screen, you see hearts popping out, right? That is real-time interaction, which is what is powered through WebSockets. Then stock market ticks. If you invest in stock market, you would have seen stock market ticker. Every second you get what is happening in the market, and the graph goes up and down and up and down. How that is happening? The backend servers of your favorite app, your stock trading app like Zerodha, Grow and whatnot, they're constantly sending data to. So first your client establishes connection with the backend, and then your stock market ticking servers that constantly emit the data to you one after another. Right? So this is why you would use WebSockets when you want to build real-time experience, something where you need server to proactively push to you. That is where you would use WebSockets. Right? So as part of exercise for you to have deeper understanding of WebSockets, HTTP 1.1, I assume all of you have it. In case you don't, write a simple HTTP web server. Use Flask, use Django, use your favorite programming language and expose a simple HTTP based REST API. Get a request, get a response, code it out. That's where you get deeper understanding. Pick your favorite language and start coding it in, right? Write a simple to-do application that takes the data, puts into DB, gets the data, sends it back to the user, build a small front end, build a small back end to get understanding, right? But specifically to dive deeper into WebSocket, there is a very good library called Socket.io. Almost everyone uses that. So try to build a chat application in Socket.io. You can find a ton of tutorials about building chat applications using Socket.io. Do that and you would see the benefits of having real-time communication. You would see those stark differences that come in when you are proactively sending data from the server to the client without client requesting for it, and you'd see how real-time, how great the user experience becomes, right? I would highly recommend you to implement this. Understand what Socket.io is. You might want to go, you may use other languages, but JavaScript preferable. You will find a ton of tutorials around it. JavaScript plus Socket.io plus maybe a MongoDB in backend. Even if you don't want to add database, that's fine. But at least build a simple chat application using Socket.io. It would solidify a lot of concepts in your head, right? And yeah, this is all what I wanted to cover in this one. I hope you found it interesting. Hope you found it amusing. That's it for this one. I'll see you in the next one. Thanks, Atul.